Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vector and parametric equations for line in R2. So as per the problem, a line is defined by the parametric equations x equals -2 minus t and y equals 4 plus 2t. T is any real number. In part A, we have to find, does R lie on this line? So we are given point R and we have to find whether it lies on the given line. So for that, we should sub in x as -9 in the given parametric equation and y as 18 in the other parametric equation, and check if we get the same value of t from both equations. So let's start with the x equation. So we sub in x as -9. Now we can solve for t by isolating t on the right side. So we should add 2 to both sides. Now we can divide both sides by -1. So I get t equals 7. Now we can do the same analysis for the y equation. We should sub in y as 18. So we should subtract 4 from both sides. So I get, now we can divide both sides by 2. So I get t equals 7. So we get the same value of t from both equations. So that means point R lies on the line. So this should be the final answer for part A. Now we can analyze part B. Write a vector equation for this line using the given parametric equation. So let's start by writing the general equation of a line in R2 in vector form. So in this general equation, R represents the position vector of an unknown point that lies on the line. R0 is the position vector of a known point that lies on the line. T is the parameter and vector M is the direction vector of the line. Now we are given the parametric equations. So we can find the position vector of a point that lies on this line from the number terms in the x and y equations. So in the x equation, the number term is -2, and in the y equation, the number term is 4. So the position vector R0 is equal to -2, 4. So we use the number from the x equation first. Next, we can find the direction vector, and for that we need to use the coefficients of t terms in the xy equation. In the x equation, the coefficient of t is -1. So that's the x component of this direction vector. And in the y equation, the coefficient of t is 2. So that's the y component of the direction vector. Now we can use these vectors to write the vector equation. So this should be the final answer for part B. Now we can analyze part C. Write a second vector equation for this line. So to write a second vector equation for this line, we need to use a different position vector for a known point on this line. And for that, we'll have to use a real value for t to find another point that lies on this line. So we should use t as 1. So if we sub in t as 1 in the x equation, I get x equals -3. And if I sub in t as 1 in the y equation, I get y equals 6. So another point that lies on this line is -3, 6. So the position vector of another known point on this line is -3, 6. Now we can write the vector equation using this position vector. So this is the second vector equation for this line. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.